brief introduction to the reproductive system. I'm going to go ahead and tell you now. Or not. Really, this is like 2 chapters in one. You'll notice that this chapter is a little shorter than some of the other chapters that you've had to study. But at the same time, there's a lot of information in this chapter. So you've got the male reproductive system and you got the female reproductive system. Some students say that one is easier than the other, and I usually get 50-50 back from my students. Half of them think the female is easier, half of them think the male is easier. It doesn't really matter. What really matters is that you first of all start off understanding the ways that both the male and female reproductive system are the same, and then start looking at the differences. So here are some things that are the same about both systems. Number one, they both produce gametes. Gametes, G-A-M-E-T-E-S, gametes are sex cells. They're not like the regular soma cells of your body, like the cells of your skin or the cells that create your hair or the cells lining your stomach. Those are all body cells, soma cells. They only undergo mitosis, but sex cells, gametes, they undergo mitosis and a process called meiosis. And it's important to understand the difference between mitosis and meiosis. Mitosis is simply cell division, it's cloning. Essentially, if I underwent mitosis right now, my body would replicate twice as much material. I'd create 2 more eyes, another nose, 2 more ears, a whole mouthful of identical teeth, 2 more arms, 2 more legs, so forth and so on. And then I would split into 2 identical me. So I would start with 1 me, and then I would become 2 me, and the 2 me's would be completely, absolutely identical. Completely identical. There wouldn't be like my clone wouldn't, suddenly say, I'm a different person all to myself. No, that clone would be exactly me. All the annoying characteristics about me, that clone would definitely have. You would never be able to tell the difference, not even on a genetic level. We would be the same, okay? And our goal in life would either to differentiate and become a specialized cell, or to simply undergo mitosis again and make more clones. Meiosis takes it a whole nother level. Meiosis is, yes, I'm going to rapidly divide. I'm going to split and become more. However, the change in this is that I'm going to seek to define genetic diversity. So I'm going to replicate my genetic material. I'm going to take this genetic material and I'm going to shuffle it like a deck of cards and randomize the genetic material that's going to each one of my clones so that I create that genetic diversity. That's why when you were born, you didn't wind up looking exactly like your parents. Sometimes we say, oh, look at him. He looks just like Fred. Doesn't he look like Fred? No, he resembles Fred, but he's not exactly Fred, which is why it's been kind of scary on Instagram, how lately they've been posting images of celebrities and finding their doppelganger from several decades ago. You may go on Instagram and find the image of Alicia Keys, where they found a woman from, I think it's like 80 or 90 years ago, who literally looks like Alicia Keys, as if she climbed in a time machine and traveled back and forth. The picture is a black and white photo. But the reason for that is because you create genetic diversity, but it doesn't mean that the genetics went away. Remember, you're shuffling a deck of cards. Those cards are ultimately going to get out on the table. And in the course of playing that game with that same deck of cards that night, you're bound to get the same card that you had at the beginning of the night by the end of the night. It's just the luck of the draw. So both male and female reproductive systems, they produce gametes. Both systems nourish and protect and store the gametes. Both systems produce sex hormones. So men, we tend to produce testosterone. Women produce estrogen and progesterone. These hormones have a direct effect on our functionality, on our growth and development, and our mental compliance and how our brain develops. Also, One other last thing is that both systems are necessary for the reproductive process. So half of my genetic material and half of a woman's genetic material are put together so that it can form an actual person. Now that you understand that and you've gotten a little update on meiosis and mitosis, let me go a little deeper with meiosis and mitosis just for a moment. Meiosis and mitosis belong to specific processes that happen in male and female reproductive anatomy. With women, your process is known as oogenesis. That is the process of gamete formation for women. For men, the process of gamete formation is known as spermatogenesis. So for women, it's oogenesis. For men, it's spermatogenesis. For men, spermatogenesis does not begin until puberty. So when you're in as a fetus inside the womb, you're not doing spermatogenesis. After you're born, no spermatogenesis. When you're 8 years old, no spermatogenesis. But when you hit puberty, spermatogenesis begins. And spermatogenesis continues until we die. That's why you hear about the random 80-year-old who got the random 20-year-old pregnant. It can still happen because he's 80 years old. His sperm count might be very low, but it's still producing sperm. So spermatogenesis in men doesn't happen until we hit puberty, and it doesn't end until we pass away. For women, this is different. Oogenesis, gamete production for women, actually begins before they were born. So around month 6, you can look at a fetus, and that fetus is actually producing gametes. It's actually undergoing oogenesis. And then just before birth, oogenesis stops. It pauses. So she's been making countless egg cells while having not even been born yet. Then right before she's born, it stops. And everything goes into pause. So nothing gets thrown away. Everything just goes on pause. The entire process of oogenesis pauses. It just stops. And then after that female reaches puberty, it cuts back on. It starts off just where it left off. And they produce 1 gamete a month. Now, I didn't mention this about the males, but males are producing I think it's 500 million. It should be 500 million sperm cells a day. Yeah, you saw that right. 500 million sperm cells a day. That's what men are producing. So once they hit puberty, they start producing about 500 million sperm cells a day versus women who are producing 1 gamete per month. And they begin producing this viable gamete at puberty. And they continue to release one once a month until they hit menopause. And once menopause has completed, they no longer release a viable gamete. For men, we're producing about 500 million a day. We typically cycle every 12 hours. Women, they cycle an average of 28 days. You have to remember that this is an average. I always warn people every time when they're in this class, remember that everybody's not everybody. So the average for women is 28. I've met people who their cycle was 14 days. They had a period twice a month. And then I've seen some people who their period was about 35 or 36 days, where they had a cycle every month to every other month almost. So that's the thing with oogenesis and spermatogenesis. You want to pay close attention to the stages. We can do another video to go into the details of the stages of spermatogenesis and oogenesis. One last thing about the reproductive system for male and female is that estrogen and progesterone for women, testosterone for men. Testosterone ebbs and flows with secretions from the man's body over a 24-hour period. Whereas when women talk about being on a cycle and they talk about, the emotional changes and how they feel, or possibly being moody, or tension, or all the different feelings that can come with the cycling of those hormones. Men go through a 24-hour cycle, and most women usually nod their head and agree, saying, yeah, I could see that. For testosterone is the dominant male hormone, versus estrogen and progesterone sharing that job in women. And we can talk about that in another video, and we can look at some charts of how they ebb and flow along with that. Aside from what I've talked about just now, one of the last things I would have to throw in here as a bonus is it's important to understand the role of the anatomy in male and female physiology, reproductive physiology. It's important to note that with the male reproductive system, it's pretty straightforward. It's actually rather simple. Sperm production happens in the testes. It takes a few weeks to make a viable sperm cell. These sperm cells leave the seminiferous tubules within the testes, and they ultimately end up in the epididymis, where the epididymis then stores and matures the sperm cells so that those sperm cells can actually become viable sperm cells. And then they leave from the epididymis through the ductus deferens, also known as the vas deferens. That's the tube that gets snipped in a vasectomy. And so it goes from the vas deferens, it merges with different glands along the way. And we'll talk about this in another video. And it then connects with the urethra, which passes through the prostate. And then it exits the urethra at the glans penis. Now, in the woman, it's a little more difficult for people to grasp the anatomy of that. And the reason why is because sperm cells enter the female reproductive tract through the vaginal canal, but a female's egg cells are coming in from a different direction. They're coming from the ovaries. And so they're hoping to meet in the uterine tube. So there's a lot more detail in female anatomy. I think for the most part, students usually agree that the male anatomy is a lot easier to learn than the female anatomy. So you don't want to do too much comparison with that. That could get you mixed up. But that's all the time we've had. I've already gone over. We'll come back with another video shortly with some talks about details with the reproductive system. Take it easy.